Hey guys, we're working on review unit 4.2. We're not going to do every problem. I just want you to do 1 and 2 out of 3 and 4. If you want extra practice with regular polygons, go for it. I tried to set up as much as I could before we start the video just so I can get through a lot of this as much as possible. If you need to rewind and go through it again, please do so. Okay, so question 1 and 2, we need to find the area of the regular polygon and the perimeter if possible. But the perimeter should be pretty easy because they're all regular polygons, which mean all sides are the same. So 9 plus 9 plus 9 gives me 27 inches. But the area is not as easy. Okay, so what we're going to do is we're going to drop the apothem, which you know cuts this in half because it's a bisector. So I get 4.5. Okay, but we still need the length of the apothem. Okay, so if I cut that little triangle out, I have this is 4.5 inches. I have that's a right triangle. I just need one more angle. Okay, well the central angle, remember, is easy to find. You just take 360 and divide by the number of sides. Well, it's a triangle, so we get 3. So the whole angle right here is 120 degrees. But that's this whole angle. I only want half of it, so that's going to make this a 60-degree angle. Okay, so now I'm going to label my opposite, my adjacent, and my hypotenuse. I don't need the hypotenuse. It could be nice to find, but I don't need it. What I really need is the adjacent side, which is the apothem. So TOA will tell me which trig function to use, which is tangent. So I'm going to set up the equation. Tangent of 60 equals the opposite side, which is 4.5, over the adjacent side. Okay, but I need to solve for the adjacent side, so I'm going to multiply both sides by the adjacent side. So I get the adjacent times tangent of 60 is equal to 4.5. And now let's divide by tangent of 60, because that's just a number, so I can do that. And then if I plug that on my calculator, I should get the adjacent side. Well, tangent of 60 is approximately 1.73. So if I take 4.5 and divide by 1.73, I get approximately 2.6. Okay, so the adjacent side right here is about 2.6 units long. So now I have a full side length, which is 9 inches. I have the number of side, which is 3, and I have the apothem, which is 2.6. So area equals 1/2 the number of sides, which is 3, times the side length, which is 9, times the apothem, which is 2.6. Multiply all that together. Let's plug it in our calculators. 1/2 in parentheses, then 3 in parentheses, then 9 in parentheses, then 2.6 in parentheses, and we get approximately 35.1. We're still dealing with area, so it's inches squared. Okay, I'm going to move over here to the right so I can get some space with this pentagon. Pentagon's 5 sides, so I'm just going to draw this right here. Create my right triangle. I have the apothem, but I do not have the side length. So if I take that triangle and redraw it, I have the apothem, which is right here. I don't know this side length down here, but I do need the central angle. So central angle, same formula, 360 divided by the number of sides, which is 5, and we get 72. Remember, that's the whole angle. I don't want the whole angle, I just want part of it, so that's going to give me a 36-degree angle because it's half of 72. And now let's set this up. I need the bottom side, which is opposite. I'm given the adjacent, and I don't have the hypotenuse, but I don't really need it. So, same idea, tangent again. Tangent of 36 is equal to the opposite side over the adjacent, which we know is 2. Multiply both sides by 2 to cancel out those 2's, and I get my opposite side is 2 times the tangent of 36. 2 times tangent of 36 is going to give me 1.45 equals the opposite side. 1.45 is this whole side right here, but remember, that's only half because the apothem bisects. So if I multiply that by 2, I get approximately 2.9 units long because it's the whole side length. So now, here's my formula. 1/2 sides, well I have 5 of them. The apothem was given, which is 2, and the side length is 2.9. Multiply all that together. 1/2 in parentheses, 5 in parentheses, 2 in parentheses, and then 2.9 in parentheses, and I get 14.5 inches squared. So we have the area. Well, the perimeter, we have each side is 2.9. There are 5 sides. So 2.9 times 5 gives me 14.5 as well. That's kind of cool. Perimeter and the area are the same. Let's take a look down here. Find the area of an octagon with an apothem of 6 centimeters. So this is a 6 centimeters. Well, I drew the triangle right here. Now I need to find my central angle, which is 360 divided by 8, which is 45. But remember, I don't want the whole angle, I just want half of it, so that's 22.5. Now from that angle, let's label the opposite, the adjacent, and the hypotenuse. I don't need the hypotenuse, I could find it, but it's not necessary. So that means I'm using O and A, which has to be tangent. So tangent of the angle, which is 22.5, is equal to the opposite side over the adjacent, which we know is 6. So we'll multiply both sides by 6. So I have 6 times the tangent of 22.5, and we get approximately 2.48. So maybe let's go 2.5. Okay, remember that's only half of the sides. That means the whole side is 2.5 times 2, which is approximately 5 units long. If you want to go to the hundredths place, totally fine. Okay, so now I need to find my area. Area equals 1/2 the number of sides, which is 8, the apothem, which is 6, and the side length, which is 5. Multiply all that together, and we get approximately 120 centimeters squared. Okay, down here to our triangular prism. So here's what I've done. For a triangular prism, you have to look at your formula, which is 1/2 base, the height of the triangle times the height of the whole prism. Well, we have the height of the whole prism. We have the base of the triangle, but we need to find the height. So what I did was I used some of our regular polygon ideas. I dropped a height, which is going to create a 90-degree angle, and bisect the tenside, which makes it a 5. Okay, so now we can use trig to find the height. If here's my opposite side, here's my adjacent side, we can use trig to figure out, well, opposite over adjacent. So tangent of 30 is equal to 5 over the adjacent side, which we don't know. Multiply both sides by a, and then we have a times tangent of 30, and then divide by tangent of 30. Okay, so if we have 5 divided by tangent of 30, we get approximately 8.6, so the adjacent side is 8.66. Well, that's my height. That's my whole height right here. So now I have enough information. 1/2 the base of the triangle, which is 10, the height of the triangle, which is 8.66, and then the whole height of the prism right here, which is 12. Multiply all that together. And we get 519.6. 519.6 meters cubed because it's volume. Okay, number 7, I can't really see the radius. So whatever that number is, I wish I could see it. You just plug that radius in. I think it might give you a diameter. If it gives you diameter, divide by 2. If not, plug the radius into that cube, multiply it all together, and you'll get your answer. Let's go over to our square pyramid. Okay, so take a look right here. We are given not the actual height, we're given this slant height right here, and we need to find the actual height. So you can drop the height and create a right triangle. Okay, now what's cool about that is if I drop the height, it's going to bisect each side, so half of that side is 5.5 inches. That's where I got this 5.5 right here. So now we have the slant height, which is the 12, we have the half of the side length, which is 5.5. We need to figure out how to find this missing side. Well, we have 2 sides, so let's use Pythagorean theorem. So 5.5 squared plus b squared is equal to 12 squared. 5.5 squared and 12 squared. So 5.5 squared is 30.25 plus b squared equals 144. Subtract that from both sides. Subtract 30.25, and you get b squared equals 113.75. Square root both sides, and we get approximately 10.67. Okay, so that's going to be inches as our height. So this height right here is 10.67 inches. Okay, so now we have the area of the base. That's what this stands for right here, the capital B. Well, let's figure this out. If it's a square pyramid, 11 by 11, so it's 1/3. The area of the base is 11 times 11, because so side times side, base times height of that square, and then times the height of the pyramid, which we found was 10.67. Multiply all that together. And you get approximately 430.36. Our units are inches, and it's always cubed. Okay, so there's the first page. A lot of work, but you guys can do this. Flip it over. Okay, take a look at our back. Fill in the ratio. So this is what we learned last class. Ratio of perimeters. Well, remember that perimeters and side lengths have the exact same ratio. So if I line up corresponding sides, 8/16, that simplifies 1 to 2. So that means the perimeter, because it's just adding up side lengths, has the exact same ratio. Now areas is different because you're multiplying a base times a height. So you have to square both of these. So 1 squared and 2 squared, which gives me 1 to 4. And then volume, you're actually cubing the units. So you have to take 1 cubed and 2 cubed. So that's what gives us 1 to 8. Okay? Find the volume. Okay, we did one of these on our word problems. We have to find the volume of the big prism and subtract the volume of the little prism. So we take volume of big, and if we subtract the volume of the little, then we will get the volume of what's left. Okay, well, volume of prisms is pretty easy. Length times width times height, because they're rectangular or square prisms. So the big one is 4 times 3 times 4. Now the little one, let's figure this out. Well, this is kind of tricky because this width right here is the same as this width right here, so it's 3 meters. So we get 2 by 2 by 3. Multiply all those together. 4 times 4 times 3 gives me 48. And 2 times 2 times 3 gives me 12. Subtract that, and I get 36. We're talking about meters cubed because it's still volume. Okay, the areas of two regular octagons. Area, remember, is side times side. So if I want to find the ratio of perimeters or the ratio of sides, which is the first thing, I have to square root that. If you look back up here, to find the area, we squared. So to undo the area, we square root. So if I square root, I get 7 to 12 for the sides. And remember, perimeter has the exact same ratio of sides, so it's 7 to 12. But now, if they're similar prisms, so they have the same ratio, what would be the volumes? So I take the sides and I cube them. Remember, volume is units cubed. So 7 cubed gives me 343. And 12 cubed gives me 1728. So that's 1,728. So sides and perimeter have the same ratio, but this time we're given the area, so we have to square root. And then the volume, you take the sides or the perimeter ratio and you cube, because units are always cubed. Okay, last type of question, a little bit of review, but it's talking about polygons, so I wanted to put this back on there. 3 vertices of the rectangles are given. Find the coordinates of the fourth, and then the area and the perimeter. Okay, so I plotted the first 3. Well, remember that rectangle has opposite sides congruent. So if this side is 1, 2, 3 units long, then the opposite side has to be 1, 2, 3 units long as well. So that fourth coordinate is +1, -1, 2, 3, 4. So +1, -4, which is good. Now let's count the sides. 3 and 3. This side is 1, 2, 3, 4, and 4, because it's a rectangle, opposite sides congruent. So area of a rectangle is base times height, which is 4 times 3, which is 12 units squared. And then perimeter, just add them up. 4 plus 3 plus 3 plus 4. We get 8 plus 6, which is 14 units. And there you go. If you look at the bottom, the last questions, complete the following constructions. These are constructions we're going to do next in class. If not, you can go into our volume folder on Schoology, click on constructions, scroll all the way to the bottom to the circle topic, and it has inscribe a square in a circle, inscribe a hexagon in a circle, and you can find inscribing a triangle in a circle. Okay, good luck, guys.